Open your book to page 51. So today's lesson is on factoring integers. So before we get into factoring itself, you need to know what number are divisible by what number. So divisibility. So on page 51, first let's go and look at divisibility by 2. So a number is divisible by 2 if it's an even number. So the last digit has to be even, and so you can divide by 2. Now divisibility by 3. The way to test if a number is divisible by 3 is by adding all the digits and see if the sum is divisible by 3. So for example, let's say if you have like a 945, okay? Is this number divisible by 3? Yes, because you add all the digits together. So 9 plus 4 plus 5 give you 18, and 18 is divisible by 3. So you add all the digits together. If it can divide by 3, then the number is divisible by 3. If it cannot, then it's not divisible. So let's say if you have 7, 2, 3, okay? I can test it out. So you add all the digits together, so this is equal to 12, so the answer is yes. Okay? Now if you have 120, let's say 5, okay? Again, you add the digits together, so you get 8. So 8 is not divisible by 3, so this one is no good. Okay? So again, you add all the digits together, you divide by 3 to test. Okay? The test of divisibility by 5. Now, if it's divisible by 5, the last digit must be 0 or 5. Okay. So those are some of the basic ones, and there are tests for different numbers, but we're not going to get to that. Okay, so next, let's go over some examples what to do with this. But before we get to that, let's get to page 53. Okay, we have to talk about the prime number and the composite number. So you have prime number and composite number. Prime number is a number that can divide by 1 and itself. Okay, you only can divide by 2 numbers, 1 and itself. So that's prime number. Composite number is when you can divide by more than 2 numbers. So let me give you some examples. So for example, like 3. Okay, so 3 can divide by 1 and 3, right? That's it. So this is a prime number because you only can divide by 1 and 3, right? You only can divide by 2 numbers. Okay. Another example of prime number would be like 7, right? You only can divide by 1 and 7. That's it. So when you only can divide by 2 numbers, it's a prime number. When it can divide by more than 2 numbers, it's a composite number. Example of that would be 4. 4 can divide by 1, 2, and 4, right? So therefore, this is a composite number. It can divide by 3 numbers. Now, how about 1? Well, 1 is neither. Okay, remember, definition of prime number is can divide by 2 numbers. 1 can only divide by 1 itself. That's it, 1 number. So this is not prime and it's not composite. Okay, so when you can divide by 2 numbers, it's a prime number. When you divide by more than 2 numbers, it's composite. And 1 is neither. Okay? And again, we only talk about positive numbers. Okay, only the positive numbers, not 0 or negative numbers. And so let's go over some of the examples. So let's go to page 56. And let's go to set 2. And let's go and do a few of these. So let's do number 2. Okay. Again, the instruction says write P if the number is prime and C if it's composite. And give the set of all the positive integral. Integral means integer. So give a set of all the positive integral factors of the number. So number 2 is 14. So first, let's go and find all the factors. And so all the factors, you don't want to write it in order. So the 14 can, so it divisible by 1 and 14, right? So this is the easy way to do it. Do it by pair, and you can do it by 2 and 7, right? Okay, 1 times 14 give you 14, 2 times 7 give you 14, right? And that's it, right? Because you can try 3, no, 4, cannot, right? So this is it. So that's what I mean by, give a set of all the positive integral factors. So all is a factor of that. And because you have more than 2 factors, so therefore this is a composite. Okay, so that's for number 2. So this would be your answer right over here. Now when you get to number 4, you have 19. Okay, so the factor for 19 would be 1 and 19, and that's it. There's no other ones. Since it has only 2 factors, this is a prime number. Again, remember, prime number can only divide by 2 numbers. Composite can divide by more than 2 numbers. Okay, so that's what you need to do with this section. Now let's go to number 18. It says find all the integral factors of each number. When it says all, it including negative numbers. So for number 18, you have 23, right? So all the number would be 1 and 23, right? And when it says all, means you have to include a negative. So it would be plus or minus 1, plus or minus 23. Okay, so this is 2 numbers here. This is positive 1 and positive 23, and also negative 1 and negative 23. So there are total 4 numbers over here. So these are all the factors. When it says all, means including the negatives. Now let's go to number 20 for number 38. Okay, so if you divide by 1, you get 38, right? If you divide by 2, you get 19. Right? So that's, again, you don't want to do in order. If you do it this way, it's easier, right? So you divide by 1, you get 38. Divide by 2, you get 19. Can you try 3? No, 4. So keep going until you get to the same number. So when you get to 6, no, cannot. So that's it. Okay? And again, this is only the positive. It asks you for all. So you have to put in plus or minus. So you have to include in the negative. So there are a total of 8. Right? Each of these is 2 numbers, right? So you have 2 numbers here, 2 numbers here, 2 numbers, 2 numbers, give you a total of 8 numbers. Now, don't get confused the factors with the prime factorization. That's the next part. So let's go to number 28. So you have 18. And they want you to, it says find the prime factorization of each numbers. So what I mean by is that they want you to find out what this number is made of. Okay? And you want to break it down into all the prime numbers. So this is what you want to do. So 18, you start with the lowest prime number. So you want to break it down into prime numbers. Just imagine that you have something, you want to break it down into its ingredients. See what this is made of. Okay, so you start with the lowest number, so divide by 2, you get 9, and after that you divide by 3 and 3. So your prime factorization means you want to break down into prime numbers, and so 18 is equal to 2 times 3 squared, and so that is your answer. So 18 is made out of 2, 3, and 3. Okay, so this is called a prime factorization. So make sure you understand the difference between factors and prime factorization. Okay, a lot of students get confused. Okay, so let's go and do a few more. Okay, let's go ahead and do number 38. So you have 72. So again, you break it down. So again, you always start with the lowest number, and you keep trying it until you cannot do it any longer. Okay, so divide by 2, you get 36. Okay, divide by 2, you get 18. Divide by 2, you get 9. Divide by 3, you get 3. So 72 is made out of 2, 2, and 2, so that's 2 to the 3 power. And you got 3 and 3, so that's 3 squared. So that is your prime factorization. Okay, you want to find out what the 72 is made of. So it's made out of 2, 2, 2, 3, 3. Okay? So that's what the prime factorization is. Okay, so let's go ahead and do some practice.